Hey everyone, welcome back to my channel. So today we'll be solving this classic problem of reversing a singly linked list. So what we would be given here is a singly linked list and we are expected to return a result of something like this. So in simple terms, just reversing the entire list and making sure that the head pointer points to the correct node and the last node points to the null. So how do we do it? Let's see. I just erase this one. Okay, so for this problem, we would need uh, two pointers and one temporary pointer. So what I mean by that is we would need a previous pointer that would essentially point to a null value or a null pointer and a current pointer that points to the head node. So these are the essential pointers that we need to have and a temporary pointer because the loop that we will be running from start to end. So there would be a loop which would run. I'd write the conditions later. And for this particular loop, uh, we would have to maintain a next pointer of the current node. And this is the temporary node that we would maintain. So this in the first iteration, what we would do is we would first assign the next temporary pointer that we created here to the value which current's next pointer points at. So it would be something like this. So next is equal to current's next. So now once we have kept a temporary value here, what we can do is now we can very safely discard this next pointer of the current node and point it to where the previous node is pointing at. So in essentially in the first loop or in the first iteration, this would point to this null pointer. So I just remove this and I'll also write it here side by side so that you be aware of what the step that I have taken. So I have reassigned the next pointer of the current node to the ones that is pointed by the previous node. So this is what we have done so far. Now what we need to do is very simple. We need to reassign the previous node to where current is pointing at and reassign the current node to wherever next is assigned at. So I'll just erase this and rewrite things. Our previous pointer would point to where current is pointing at. So previous would be reassigned to wherever current is at and current would be reassigned to wherever next is at. So this would be current's new position. So the first iteration is done and we would have to keep on doing it till our current value or the current pointer points at this null position. So the loop's condition would be current should not equal to null, and if it is null then we would break away. So let's see, in the second iteration, as we have written, the next pointer would be reassigned to the current's next value. So I'll just erase next from here and this would be its new position here. And now the current's next pointer, which is this one, this is the pointer, it would be reassigned to wherever previous is pointing at. So this is gone and now the next pointer of it is pointing to wherever previous is pointing at. Previous would be reassigned to wherever current is at. So this would be the previous's new position and current would be reassigned to wherever next is at. So I'll erase the unnecessary bit now. Okay. Similarly, I'll just move on. Like the next would move to wherever current's next is at. So the next iteration. The next pointer of the current node would now point to wherever previous is pointing at. Previous would go to wherever current is pointing at. Current is pointing to wherever next is pointing at. So I'll erase the unnecessary bit again and clean things up a bit. So here is the previous node. Okay. So now another iteration. Next would go to the current's next. Current's next pointer would be reassigned to wherever previous was pointing at. Previous would be reassigned to wherever current is at. Current would be reassigned to wherever next is at. So again, the same exercise, cleaning up a bit. And this is the previous node. So this would be the last iteration. So next would move to wherever current's next is pointing at. So it doesn't matter if it is null. We do not really care about next's value. The current's next would now point to wherever previous is pointing at. Previous would now be reassigned to where current was and current would then move to wherever next is. So I'll just erase. So things are looking great now. Now we eventually are at the place where the current's value is null. The loop would break and that's the end. So now what we would return, we are not supposed to return current, we would return previous. So this pointer is our new head now. And if you look carefully, if we start from here, it gives us 4, then it gives us 3, then it gives us 2, then it gives us 1, then it gives us 0, and 0 then at the end points to null. So it's basically what we hope to achieve, we got it. So this is our answer. And to talk about the complexities, the time complexity is pretty easy. We just had one loop and we iterated over each and every element. So it's like O of n, n is the number of nodes. And space complexity, we didn't really use any additional spaces or any auxiliary spaces. So it is O of 1. It is pretty straightforward. So with that being done, so this was a warm-up exercise, I would say. There is a slight variation of it and it's a pretty interesting variation. So I'll rewrite it. So in lead code, if you search for it, they call it reverse singly linked list, singly linked list 2. So this is the second type of it, and in some places I've seen they call it reverse sublist. So sublist is like a subsection of the list. So let's consider the same like singly linked list. So it have 0, 1, 2, 3 and 4. It points to null. So in addition to this head pointer, we would also be given two more values, L and R, the left bound and right bound. So for example, let's say I'll just write the indices of it. So linked list for this particular condition or this question, it was a 1 based index. So I'm just writing that down. So they would be giving some values of L and R. Let's just consider 2 and 4. I think that's the values which is present in lead codes problem as well. So we'll go with that. So what they are asking here is they would be giving a linked list head node and they would be giving us some left bound and right bound, and we need to make sure that we reverse the linked list portion demarcated by this left and right bound. So what do I mean by that is we would have this section of the linked list intact. So this would remain as is, but the things that are inside it, they would have to be just reversed. So instead of 1, we would start with 3, 3, 2, and then it would be 1. So this would be our result, and obviously this would be the head node. Okay. So this would be our result. So it could be anything. L is like less than or equal to, greater than or equal to like 1, and R is less than or equal to 5. So they could even give L1 R5. So it would essentially be the first problem that we solved, the type 1. But here is a trick. We need to make sure that it works for any value. So how do we do it? I'll erase these information. Okay. So we already solved the simple reversing of a singly linked list. So the idea is same, but we need to take care of some things extra. So we would have to create a dummy node. So there would be a dummy node. We do not care about the value, so we'd assign it or initialize it with 0. And the dummy node's next pointer would point to head. So this is the first step. So the first step was create initialize, which is the technical term, a dummy node. So first step is done. Second step, I'm not writing it exactly here. I'll just show you. We need to have some pointers, obviously, just like the first one before. We need to have some previous pointer and some current pointer. So the current would point to head and previous would point to the dummy node, because that is the previous node of the current node. So now what we need to do is we need to make sure, or we need to iterate over the loop and bring the current node to wherever the left bound is pointing at. So this is the left bound point. So we need to bring the current node here, and so how many iterations would that be? So here in this case it is one iteration where the else value is 2. So in general it would be L minus 1 iteration. So we would need to have a loop that takes like L minus 1 iterations, and it's pretty simple. What we need to do, it's actually similar to the ones that we already have been doing. So we do not have to reverse anything. We just have to move the current pointer and along with it the previous pointer. So it would be something like, first move the previous to wherever current is pointing at, previous would move to wherever current is pointing at, and current would move wherever current next is pointing at. So let's do it. What we get is, first move the previous pointer to wherever current is pointing at. Okay, so this is the previous pointer. Let's move previous pointer to wherever current is at. So here is the previous pointer, and current would be reassigned to the next value. So this is the current's new position. So with that, for this particular problem, we have completed our iteration. So in general, in any case, like if it was L equals to 3, we would have to move again, and then we would reach the position where L is equal to 3. So it's basically L minus 1 iterations that we need. So now what we need to do, once we reach here, we need to create a temporary variable, and it's not actually temporary. We would have lots of use cases for it. I'll just call it temporary, or temporary previous rather. So what we do keep track of is, we need to now like reverse this particular subsection of the list. And to reverse the linked list, so this is, if I consider this is a independent linked list, then we always needed a previous pointer. So if you remember the ones that we solved, we had a previous pointer and pointed it to null. So similarly, in this case, before starting off with anything, we'd have a temporary previous pointer and point it to a null value. So this is what we need to do, third step. And the fourth step would be, we need to make sure we move our current till the end of the right bound and after it, like the next node of the right bound. So if right, for this particular scenario, right is at 4, so we need to move our current pointer to 5. If right was at 5, we need to move our pointer to this null. So whatever the right bound is pointing at, we need to move our current pointer to the next of this particular right node. So how many times do we have to iterate? It's actually, in a general case, it would be r minus l plus 1. So the third step is here. I'll just write the fourth step here. We need a loop, and the loop would be r minus l plus 1, because r minus l would give us this much, and we need to move once ahead. So r minus 1 plus r minus l plus 1. R minus L plus 1, it's 3. So we would have loop these many times, and what we would do here is, we would do the same thing as we have done. Only thing is that we have changed the name of the variable. So for us, this previous node is now temporary previous, current is current, and this next is a temporary variable within our loop. So it's the same thing. Here we would do the same thing. Next is equal to currents next. So we just keep a copy of wherever currents next is at. Then we would like break away this connection. So this is currents next. If you remember, currents next would now point to the previous one. For us, it is temporary previous. Currents next would now point to temporary previous. And temporary previous would be reassigned to wherever current is at, and current would be reassigned to wherever next is at. And that's it. So I'll just do it. I'll just do one by one step. First step is, we need to make sure next is pointing at currents next. So this is a next variable here. Now currents next, which is this particular pointer, should be reassigned to wherever temporary is pointing at. So I had to reassign this to this particular place. So it is now broken. I just remove it. Okay. Now temporary previous is assigned to wherever current is at, and current is assigned to wherever next is at. I'll just write them together. So now the temporary previous would point to this particular node, because this is where the current pointer was, and current pointer is now pointing to wherever next is at. Okay. So one iteration is done. We need to make sure we do 3 iterations. So this is the result of first iteration. Now we are moving to the second iteration. First things first. Next would move to current's next position. The next pointer of current points to wherever temporary previous is pointing at. Temporary previous would point to wherever current is at, and current would be reassigned to wherever next is at. Just clear things a bit so it appears more nicely. So this is how the state of things are after the second iteration. Similarly, we would have to do it one more time. Next is at here, break the currents next, re-establish it with the previous temporary previous, assign it to wherever current is at. I'll just erase this. Assign it to wherever current is at, and current would move to wherever next is at. So this is the temporary previous, this is the current, and we're done with next node because once the loop ends, the next variable is automatically destroyed, so we do not have to worry about it. And I'll just rewrite things. Okay, so this is the state of things after 3 iterations, or the iterations that we needed. Now the last but not the least step is re-establishing these loose ends. So if you remember, I'll just draw the resultant linked list that we are expecting. 0, then 3, then 2, then 1, then 4, and then null. I'm not writing the head because there is no space, or maybe I'll write it. Let it be. Okay, so what is happening here is 0 should point to 3. Currently 0 is pointing at 1. So we need to make sure 0 is pointing at 3 in this way. And 1 is pointing at null here. 1 should point at 4. So what we need to do is, before breaking this connection, we need to establish this connection. I'll just do a dotted line thing. We need to establish this connection, and we would use current pointer and the previous dot next dot next. So something like this. Previous, which is this node, dot next is pointing to this node, but we need to re-establish this one. So we do another dot next, and this would be reassigned to wherever current is at. So once this is done, we can then safely remove this connection and reassign this particular value to wherever temporary previous is pointing at. That's why I said it may look temporary, but it has a significance. So if I remove all of these things and rewrite, I think we would achieve the result. Let's see. Again, previous dot next dot net. So there was a connection. So previous dot next, it was here, something here. We would have to do it or reassign the connection to wherever current node is pointing at. So now this is done. This is now meaningless. We have to reassign this particular node. So previous dot next is what we are interested in now, and it should now be reassigned to wherever temporary previous is pointing at. So it should be something like this, and we break away the existing one. So let's see if we get this desired result. 0 to 3, then to 2, then to 1, then we go to 4, and then to null. Yes, we have achieved this, and this is how we need to do. But another crucial thing is returning the node. Which node? We should always return dummy dot next wherever dummy is pointing at. We should not return this head node, because imagine a situation where L is equal to 1 and R is 5, 3 or 4, whatever. So this would actually change if L is 1, and so would the pointer of the head node. So in any case, if dummies dot next is here and previous node is keeping a track of it, so we do not have to worry about what is this node. We just simply return dummy dot next, and that would be our new head. That's dummy dot next, sorry. Dummy dot next. Okay, what about the time complexities and space complexity? So these are pretty easy. So time complexity is similar to what we have already done, O of n. But why? It's because we have done a partial loop here and a partial loop here. So together it would make O of n, and space complexity would be O of 1, because obviously we didn't use any auxiliary spaces, only constant spaces have been used. So yeah, the space-time complexity is similar to what we have already seen in the earlier problem. So yeah, this was a nice variation of the existing problem. So I have already put up the C++, the Python and JavaScript solution in the GitHub repo. I'll put up a link in the description as well. So do check that out and let me know if you guys have any questions, any problems, or any feedback. I'd like to incorporate those, and as I make newer videos, I'll be solving lots and lots of problems later on. I hope you guys like this one. Do comment, share, subscribe. Thanks a lot. Bye bye.